Hi everyone, in this video I'm going to show you how to work with raster data in an R environment. I'm going to show you how to use the most popular functions when working with raster data and how you can modify and export the data that you're working with out of your R environment. So here is a list of what we're going to be working on. We are going to import the raster, reproject it, crop it, resample it, change the resolution, turn it into a data frame, and then export it. These are very popular ways of modifying raster data, and we're going to go over all of them. And if you have any questions, you can just let me know in the comment section. So let's get started. So the first thing we want to do is import the libraries that we're going to be using. We are going to be using two main libraries. That's the Terra library and the SF library. So that's Terra, and that's the SF library. So I'm going to import both of them here. You can see that I have no issues importing them. The Terra library is very popular for working with raster data or any sort of Earth observation data. And then the spatial feature, the SF library stands for spatial features, and that's what you use when you want to work with vector data, so shapefiles, GeoJSONs, things like that. And we're going to be using both libraries in this video. Okay, so to work with raster data, you obviously need raster data. And I'm going to work with a file that I have on my computer. So I'm working with land surface temperature data, and so I'm going to call my variable Washington LST because it's over Washington. And to import the raster, we use a function called rast. So it's RAST, that's from the Terra library, and then in that function, you want to input the file path to where your raster file is saved. So that's where my raster file is saved. I just put it on my desktop. So I put the file path in the rast function, and I'm going to run it. So let's highlight it and run it. And you can see it was imported, and I'm not getting any errors. And so that means it was imported without issue. If we want to plot the raster function, it's very simple. You just use the plot function, and then you input the variable of the imported raster. So let's do that. Washington LST, and you can see it pops open pretty simply, just like that. So there's my raster, and it comes with a legend. And if you want to modify that, there are ways to modify it. So let's take a look at the Washington LST variable and see what a raster looks like when you import it. So I'm going to put the variable name in the console and then just click enter. So this is what a raster looks like when you've imported it. You can see the class is spat raster, which makes sense. It gives you the number of rows and columns in the actual raster grid. It gives you the resolution, so the size of each of those grid cells. It gives you the max and min boundaries of the raster, the coordinate reference system, and then the name of the variable. So the name here is LST because it's land surface temperature. And depending on whatever raster you're working with, these values will obviously be different. Okay, so we know how to import a raster, plot it, and view it. The next thing we're going to do is reproject it, which is a very common thing people do when working with raster data. So I'm going to change the projection. You can see the projection here is EPSG 4326. I'm going to change it to another coordinate reference system of my choosing. So to change the projection of a raster, we're going to use the function called project. So that's what it looks like. I'm going to call this variable LST underscore reproj for reproject. In the project function, you need to provide two arguments. The first one being the raster you want to reproject, and then the second argument being the new coordinate reference system. So the raster that we want to change is obviously Washington land surface temperature. So I'm going to put that in there. And then I'm going to change the coordinate reference system to 2169, and it's going to be the EPSG coordinate reference system. Let's run that. Okay, no issues there. So let's take the variable, place it in the console, and then click enter. And you can see it now has a brand new coordinate reference system. The original one looked like this, And now here's our new one. So a very easy way to change the reference system for your raster. We are going to continue using the original raster because it's a more familiar reference system, but if you want to use the reprojected one, you can just use that variable name in the rest of the code. Okay, so the next thing we're going to do is crop and mask rasters. I have a dedicated video for this if you just want to learn that, but we're going to go over it here again. So I'm going to crop it to a shapefile that I have. So obviously we need to import the shapefile, and that's where the new SF library comes in. I'm going to call my shapefile small circle, and we're going to use a function called st_read, and that's the function you use to import shapefiles. So same thing as the rast function here, we put in a pair of brackets, a pair of quotation marks, and then in the quotation marks we put in the file path to where your shapefile is saved. So my shapefile is saved on my desktop, so here's my file path. I'm going to run it, and then I can show you what it looks like by plotting it, small_circle, and it's just a circle. And I already know that the circle fits within the boundaries of my raster. So obviously whatever shapefile you use, it has to spatially be in the same area as your raster, otherwise there's nothing to crop. We can also take a look at the properties of small circle. You can see it's a polygon, there's only one feature. The reference system already matches my raster, so this is important. Make sure that the reference system for your raster and your shapefile match, otherwise you can't crop it. Okay, so we've imported our shapefile. The next thing we want to do is crop our raster. I'm going to create a new variable called lst_cropped, and we're going to use a function called crop to crop our raster. We need two arguments for the crop function. We need the raster that we want to crop and the shapefile that we want to use to crop the raster. I'm going to crop the Washington LST raster, and I'm going to crop it using small_circle. Run that, and we can plot it. Okay, so you can see it's smaller than the original raster. We can also verify that by looking at the extent. So let's pull open the LST cropped variable. You can see here are the xmin and xmax values. And if we compare that to the original, which is Washington LST, you can see the values change. So we have a higher Ymax, and we should also have a higher Xmax, which we do. Okay, so that's how we crop it. I also want to show you how to mask a raster. So let's create a new variable called lst_masked. And again, it's very simple. You use the function called mask, and you input the name of the raster that you want to mask out. I'm going to use Washington LST again, and then the box or shape that you want to use to mask the raster. I'm going to again use small circle. Run that, no errors, which is great. And we can plot this as well. So plot LST masked. And there you go. You can see that everything outside of the shapefile has been hidden. Keep in mind that when you mask a raster, you're not cropping it. The original raster is still there. All you're doing is hiding or masking values that fall outside of a certain boundary. So if we can confirm that by looking at the original extent, which is right here, and then the LST masked, and you can see there's the original, there's the new one, they're identical. So they both have the same extent. It's just with the mask function, you're hiding some values. Okay, so the next thing we're going to learn is how to change the spatial resolution of a raster. Sometimes you want to make your raster a bit higher resolution or lower resolution, and there's ways to do both of that in R. So again, we're going to modify the Washington LST raster, And the first thing we're going to do is make the raster have a higher resolution. And we're going to use a function called disag for disaggregate. So let's create a variable name. I'm going to call mine lst_disaggregate. And the function we're going to use is called disag. That's from the Terra package. And like every other function we've used, we have to provide a series of arguments. The first argument is the raster that we want to modify. So I'm going to modify the Washington LST. The next argument we want to provide is the level of disaggregation. So how much finer of a resolution do you want? And you can provide one of two numbers. You can provide a single number, which will essentially multiply the number of rows and columns by that number. Or you can provide a vector of two numbers, which is the level of disaggregation on the rows and the level of disaggregation on the columns. And if you're confused by this, don't worry, I can show you what I mean. So let's pull open the Washington land surface temperature in the console. So if you look at the dimensions here, you can see we have a number of rows, which is 1271, and a number of columns, which is 1871. The number that you input here will be multiplied by the number of rows and the number of columns. And so you'll have, if I were to use 9, I'll have 9 times 1271, and that'll be my new number of rows. And I'll have 9 times 1871, and that'll be my new number of columns. So when you increase the number of rows and the number of columns in a similar extent, you're going to have a much higher resolution raster. So let's stick with the number 9 as our disaggregation factor. And then finally, the function needs a way to input values into those cells. So the argument is called method, and I'm going to just keep it a bilinear interpolation. So bilinear. And what this means is that when the function is creating a new raster, it's going to estimate values using a bilinear interpolation of surrounding cells. So this is really important. It's dependent on the type of raster you're using. And you can see what the other options are by using the console. We can do question mark and then disag and then enter. And that'll pull up a window that will give you a breakdown of the function. And you can see for method, you can have either near or bilinear. So I have a continuous variable, it's land surface temperature. So I'm happy with my bilinear interpolation. But if all you want to do is grab the nearest cell, you can do near as your method. Okay, so let's run that. It might take a couple seconds. Okay, so the function finished running, and you can see it here. And depending on the size of your raster, it might take a couple minutes or even a couple seconds. So just be patient with that. So let's take a look at the new variable here. And this is what it looks like. We're gonna plot it as well, but I just wanna point out something. So you'll see here that here's our original number of rows and number of columns. And now we have values that are significantly bigger because we have a lot more grid cells. And if you do the simple math here, if we do the number of rows in the original raster multiplied by 9, you can see it matches what we have in our new raster. And if you were to do the same thing for the number of columns, it would be 16,839 columns. So that's how the disaggregation function works. We can also plot it to see what it looks like. And there it is. So it's probably hard to tell, see the differences, but it is a higher resolution, and you can pretty much export it and compare the two if you'd like, but that's how you increase the spatial resolution of a raster. So let's get rid of that. Okay, so the next thing I want to show you is how to aggregate cells in your raster. So essentially we're trying to lower the spatial resolution of your raster, and this is useful if you have multiple rasters and they all have different resolutions and you need them to match. This is a great way to get them to match. So the function that we're going to be using is from the Terra package again. It's called Aggregate. So we can pull it up right here in the console using the question mark sign, and it'll pull up in 3 different options for aggregate because there's many different types of functions that are called aggregate. I'm going to click the second one for raster and vector data from the Terra package. And you can see a breakdown of how the function works here. Let me open the window. So here's what the function looks like. And it takes in 3 main arguments. The first one is the raster, of course, that we want to aggregate. The second one is the factor. So the factor is a number that is used to combine cells into a new cell. So it'll take the factor in the x direction and the y direction and combine all of those cells into a single cell. And I'll show you what that means in the code later. And then finally, we have the function or fun, and that's the function that's going to be used to calculate the new cell. So those are the arguments, and I'll show you what they look like in practice. Let me close this window here. So let's create a new variable, LST aggregate. And the function is obviously called aggregate. We know which raster we want to use. It's the Washington LST. I'm going to set my factor to 9. So it's going to take every 9 cells in the x direction and every 9 cells in the y direction and combine that into a single cell. And then for the method, I'm going to set that equal to, for the function, I'm going to set that equal to mean. So when it's taking the 9 cells in the x and y direction, it'll look at the mean value and then use that as the new cell. So let's run that. And you'll notice that it's a lot quicker than the disaggregate function. And I want to compare the values from this aggregate LST to the Washington raster, and we can look at how the values differ from each other. So let's pull open the LST aggregate. That's what it looks like. And then let's pull up the Washington LST, which is the original. So you can see the dimensions are quite different. We have a lot fewer rows and fewer columns than in the original, and that's because we combined a lot of the cells into a new, more coarse raster. So let's plot the new raster and take a look at what it looks like. So plot LST aggregate. Okay, so here's the new raster, and you can see that there's some missing values here, and there's a reason for that. Let's pull open the Washington LST raster as well, Washington LST. So if you look closely at the plot, there's some white spots here. Those are missing values. And when you have missing values in your raster, it's going to carry over into an aggregated raster. So if you have a region with 9 cells in the x and y direction, and there's a missing value, it'll set the new aggregated function to NA. So what I mean is, even if you have 8 values, those values will be ignored and the new averaged raster cell will still be NA because you don't have a complete data set. If you're okay with the missing values, you can keep it as it is. But if you want to remove the missing values, all you need to do is add an additional argument, which is na.rm equals true. And this means that you want to remove all the NA values and just calculate the average raster value based on what's there. So let's run that and then plot it again, LST aggregate. And you'll see that it removes all the missing values because it's just using the data that's available to calculate the average. So that's how you can fill in those gaps there. Okay. One of the most popular things that people do with raster data is turn the raster data into data frames, and I can show you how to do that as well. So let's clear the decks here. To turn a raster into a data frame, the function is called as data frame. I'm going to turn the LST aggregate raster into a data frame. So let's create a new variable, lst.df for data frame, and the function is as data frame. All we need to do is input the raster that we want to work with, and then click enter or run, and that's it. We can view the data frame, lst.df, and you can see all the values have now been turned into a data frame. I personally don't find this data frame that helpful unless I know where this data is coming from. So I want X and Y values. And to do that, all you need to do is set X, Y equal to true, like that, save it, and you'll see that now when you pull open the data frame again, it has X and Y values associated for each land surface temperature variable. So that's that. And if you want to export that to a CSV, you can just you can use the write CSV function. So write.csv, the name of the raster, the name of the data frame you want to export, and then you can give it a name. So sample dataframe.csv, you can run it, and it'll save it to your working directory. Now, if you want to export the raster itself, not a data frame, but the actual TIFF, we can do that as well. The function is write raster, like that, from the Terra package, and you need to input two things. Number one, the raster that you want to export. So for me, I'm going to do the aggregated land surface temperature raster, and then you just give it a name. So lst.tiff. If you want to hard code the full file path, you can do that here. So you can set, desktop, whatever file path you want to work with, and it'll save it to that location. But I'm just going to keep it as land surface temperature TIFF, and then run that. And there you go. It'll save your TIFF file to whatever directory you've set. So that's that. Those are the most popular functions that people use with raster data in R. I hope it was helpful, and if there's anything else that you want to see for R programming, let me know, and thanks for watching.